Alright, mean value theorem and Rolle's theorem. Let's get started. Alright, Rolle's theorem. This is kind of round 2 on intermediate value theorem with the idea that you just got to have a little bit of common sense here. Here's what Rolle's theorem is telling us. If we have zeros at both A and B, right, so f of A equals 0 and f of B equals 0, and our function, regardless of what it looks like, is continuous, right, continuity, and differentiable, right, then at least one point here, we know the derivative would equal 0. So in this case, looks like I've got 3 points, right, but at least one point C, right, we would have a derivative equal to 0, right, or a horizontal tangent line. That's Rolle's theorem. Okay, so here's the proof for Rolle's theorem. I'm not going to go through it, but have some common sense. Alright, let's introduce you here to the mean value theorem. I'm going to use a different sketch here for a moment to talk mean value theorem. So let's say we have a function from A to B. Right. What the mean value theorem says is that the slope of the secant line, right, the slope of that line will be equal to the slope of the tangent line, right, that would be our form. So the slope of the tangent line at least one point if this interval is continuous and differentiable between A and B. So the slope of the secant line, how would we calculate that? That would be f of B minus f of A over B minus A. And the slope of the tangent line, how do we represent that? Well, that's f prime of C. That means that there's a slope equal to that blue slope at least one point, right? Parallel to that tangent line at least one point on the function. Now in this case we got more than 1 point, but that's the mean value theorem. So the mean values theorem says that there exists, mean values theorem says there exists a C between A and B such that f prime of C is equal to f of B minus f of A over B minus A. Alright, so let's do some application of that. Okay, kind of what I just wrote here, formal definition though. What they do is they rearrange a little bit. If f is a function continuous on A to B and differentiable on A to B, then f of B minus f of A equals f prime of C times B minus A. All that is f of B minus f of A over B minus A equals f prime of C. This is the slope of our tangent line. This is the slope of our secant line. All that's going on here is multiplying by B minus A on both sides. Alright, so you get f of B minus f of A equals f prime of C times B minus A. Alright, let's try some examples with that. Proof of the mean value theorem for your extracurricular reading activities. Okay, show that the given function f satisfies the mean value theorem on the given interval A to B. Find all values of C such that the slope of the secant line is equal to the slope of the tangent line. Okay, so let's show that f of 2 minus f of negative 2 over 2 minus negative 2 is going to be equal to the derivative of our function, right? The derivative of f of x equals x cubed at some value x. We're going to figure out what that value is. Okay, so f of 2 would be, would that be 8 minus f of negative 2, which would be negative 8 over 4. So we want to show that 16 over 4 equals f prime at some value c. So we want to find where the slope on this function would be 4. Well, what I would do is I'd take the derivative of f of x. The derivative of x cubed is 3x squared. And then solve for x, and that will be c. So I divide by 3 on both sides. I get 4/3 equals x squared. And therefore x would equal plus or minus the square root of 4/3, which would be plus or minus 2 over root 3. So at c equals, that tells us that f prime of 2 over root 3 and f prime at negative 2 over root 3 will both be equal to 4. We found where the slope is 4 on that interval for that function. Alright, let's also attempt this on part B here. So let's show that f of 6 minus f of 3 over 6 minus 3 equals f prime at some value c. Okay, so f of 6 would be the square root of 4. F of 3 would be the square root of 1 over 6 minus 3. So we're going to find the value c for which this is true. So that'd be 2 minus 1, which is 1 over 3. We want to know where on the function our derivative would equal 1/3. So we have to do a little bit of derivative work here. F prime of x would equal 1 over 2 square root of x minus 2. Right? That's going to be using the power rule, right? So x minus 2 to the 1/2 power. If I take the derivative of that, I would get this. Alright, so I'm going to set 1/3 equal to that. So if 1/3 equals 1 over 2 root x minus 2, I'm going to solve for x, and that'll be my value for c, for which the slope of that function is 1/3. Okay, so I'm going to cross multiply. It looks like I'll get 2 root x minus 2 equals 3. That means root x minus 2 will equal 3/2. That means that x minus 2 will equal 3/2 squared, which is 9/4. And then I'm going to go ahead and add 2 to that. Well, 2 is really 8/4, so I'm going to get 17/4. It looks like our c value, f prime of 17/4 equals 1/3. Alright, that'll be it for today on mean value theorem and Rolle's theorem. Have a good one.